Okay, this tutorial is for section 3.3 in Math C30, and we're going to be looking at the law of sines. So I just did a little bit of a summary here of what the law of sines is. It's derived for you in your book, so I'm not going to redo that here or in class probably. And what it basically states is that if you have a triangle where the little letters stand for the sine and capital letters stand for the angle, and the sides are always named as opposite sides to the angle that they have, we have this relationship: A over sine A equals B over sine B equals C over sine C. But be aware that when you're doing the law of sines, because sine can be positive in both the first and second quadrant, you have to be aware that what type of angle you'll be looking for, an acute or an obtuse angle. So the obtuse angle is obtained by using the acute angle that you would get when you input it into the second function or inverse sine on your calculator. You just subtract it from 180. So that's something you have to always be aware of, and we're going to look at an example or two of that. So in this tutorial, we're going to solve a couple of different triangles here, starting with this one here using the law of sines. And we're just going to do that. Let's just center that a little bit. We're just going to do that using the law of sines. So the first thing is, in the first triangle, it's drawn for us, but don't always go by the diagram of your triangle, because it might not be to scale when you're trying to find an angle or something like that, if you're assuming that it's going to be obtuse or if it's going to be acute. Always kind of rely more on what they tell you in the question or what your reasoning will tell you. So here, first of all, we have to change this angle into decimal degrees. So that would be 58 degrees plus 17 over 60 for our decimal place. So if we take our calculator out and we go 17 divided by 60, we get 58 degrees, we'll put it up here, 0.28 and a repeating 3. So I'm just going to put a couple of 3's in there. Okay. Same thing for our angle B. That's 37 degrees and 28 minutes. So we have to go 37 plus 28 minutes over 60 degrees. So we'll put that into our calculator. And that would be, and we'll write it here, 37.4 with a repeating 6 in there. So we want to find all the other sides and the angles. So first of all, we could find angle C by using this fact that an angle, all the angles in the inside of a triangle add up to 180 degrees. So angle C is going to equal 180 degrees subtracting 37.466, and we'll just use 3 decimal places. I think will be accurate enough. Subtracting as well 58.4, oops, 28, got the wrong one there, 3. So if we plug that into our calculator here, 180 degrees, subtract 37.466, subtract 58.283 equals 84.251 degrees. Probably going to be more than accurate enough for us to work with this. So now we can apply the law of sines to calculate the sides here. So here would be side C, here would be side A, and here would be side B. So we know that the given one is B. So 18.6 over the sine of what's given to us, 37.467, I guess I should have rounded it off. That would, if I change this to a 7, that would change this to a 0. Right? I should have been rounding off there. Okay, so that's going to equal the side A over the side of sine of angle A. And angle A in our case we figured out to be 58.283 degrees. So we can calculate that one, and we can do a similar one here. The given ratio. And this time we put it in our other side that we're trying to calculate, side C, over that angle that we calculated for angle C, and that was 84.25 degrees. Okay, so we'll plug in our numbers here for the sine and calculate what we get here. Okay, so we have to do some cross multiplication. So when you're doing it, just you can write it out if you like. So this would be 18.6 sine 58.283 equals A sine 37.467. And then you divide out the signs to get A. So in this case, I would have 18.6 times 58.283 sine, okay, and then divide by the other sine, 37, divide by 37.467 sine equals 26.0. We'll go to one decimal place for A, and we can do a similar setup for C. So I'll do that right here. So this would be 18.6 times sine. See, I forgot to put sine there. Sine 84.25 equals C sine 37.467. And I'm crowding it in there, but divide by its sine of 37.467, and you'll get your answer for C. So we'll go 18.6 times 84.25 sine. Okay, and then divide by 37.467 sine to get our answer for C at 30.4. And that would give us our two answers for that first calculation there. Okay, I'm going to do one with an obtuse angle in my next tutorial here. And we're just running out of time here, so we'll save it for the next one.